How did the homework go? All right. One note about the homework, and that is, okay, we got, I don't know how many sections. I'll look at the calendar here in a second. We got 1, 2, 3, 4, 5, 6, 7, 8, plus a review, 9. That's going to cover 3 weeks. Are we going to forget what we did yesterday? Oh, yes, we will. So when we get to quiz and we get to test day, this has got to be on a resource card. I will put one of these on the quiz where you have to calculate the square root without a calculator. Okay. One will be on the quiz, probably one on the test. You need to have those steps written down. Okay. All right. Any questions on the homework? Nothing?
Okay, Mr. C, you don't have to start throwing things at me, okay?
Have I thrown? I've never in my speaking career ever thrown anything in anger at a student. I said in anger.
Oh, you don't need to throw it in anger. You already got that.
I don't. I literally just said, are there any questions? Oh, no, we're not going to do it again.
I mean, can I get like a phone call?
The stuff we did yesterday. Yeah. We can do it for right for the quiz, but not today. All right. Any questions?
No.
Number 20. So number 20 is 1.6, and it says you got to do it to the nearest hundreds place. What I made. So using the technique that we learned, we got 1.6. So what two perfect squares squeeze 1.6? 1 and not 2. 1 and 4. Well, it's awfully close to the square root of 1, right? Which is 1. So our guess is, what's the most obvious guess?
1.6.
Okay. Yeah, but how close are you to 1?
2.
What? You're so close that you're basically 1, right? So my guess is 1.1, right? If I guess 1.2, remember, the middle between the two would be 1.5, right? That would be smack dab in the middle between this number and this number. Because remember, square root of 1 is 1, square root of 4 is 2. Halfway is 1.5. So is your number close to 4 or is it close to 1? How close? Really close or not really close? Really close would be 1.1. Because remember, we only go to 1 decimal place. Okay? So from that procedure right there, now we have to, I don't know, we have to do that long step procedure. So our guess is 1.1. What do we do with 1.1? Divide it into what? Perfect. So we go 1.1 into 1.6. All right, you do that math, you get an answer. Let's say that the answer is, I don't know, I'm making this part up, but let's say it's, I don't know, after we move everything, let's say it's 1.2. Now what? What do you do with those two? No, we just did the division. We add this number and divide by, and whatever that is, round to the nearest hundreds place, because I said to the nearest hundreds, and that's your answer. Okay. All right. Obviously, I skipped the entire long division. That's the challenge of that procedure right there. No, she turned on her special powers and she's invisible now.
What? Where did she go?
All right. Okay, so we got a really important class today, so there's no more questions. All I'm going to do is collect homework today, so pass it to the left. Pass it to the left. No, this is pretty, it is crazy important for the rest of the chapter, but it is not hard at all.
We're going back to shapes.
Why are you doing a big deal?
Shapes are annoying.
You'll be fine. Wednesday.
You have no facial reaction.
Next one here for first. All right. In the scope of things that are memorable and not memorable in math, today is one of the most memorable classes that you will ever take. All right. If you ask the average adult that has at least a high school education, tell me something smart about math, today is what they usually talk about. You ask your average adult anywhere in the world that's been at least through high school, tell me something you learned that's high level math, it's today, right?
Is this just the easiest to remember?
It is, it can be. I mean, I'm not going to say it's really simple like 2, right? But it is definitely memorable. All right, so your homework is 1 through 21 all. There's a lot of these. You need lots of practice. This is the foundation for the rest of the chapter. What's up, Jaden? Where did it go? Okay.
We're skipping it. Where did what go?
Just write this down. Don't worry about 1.3. It's not that I skipped anything. I'm combining things. This is why you listen carefully.
What is the smartest?
Okay. Hush, hush. Write it down. Don't get off track. So, I rarely have a student that doesn't get today's class. However, if you are that student, do not be afraid to stop me as I'm teaching and, hey, I don't get it. What are you doing? Make sure you do that. Okay? But rarely do I have a student that actually gets lost on this stuff. It's pretty straightforward. Okay? Here we go. Today's class, this thing's having issues on clicking. Today's class is on Pythagorean theorem. 2 words that you've never encountered before, Pythagorean and something called theorem. I'll explain them both to you. All right, Pythagorean theorem, let's explain both of those words. The first word or the second word you see there is theorem. This entire book, they just slammed on the floor and scared everyone. This entire book, high school geometry, is nothing but theorems. We're going to learn 1 theorem today. This entire year of study is about theorems. If I open it up to almost any page, what does it say? It says theorem 6.1. If I open it up to almost any page, theorem 9.9. Almost every, except for the exercises, almost every page in this, right, if I randomly open up, has a theorem in it. There are over 100 theorems that you will learn high school geometry. Today you learn 1, and it's a very easy one. A theorem is what's called a truth in math. Right? I'll give you an easy theorem in math. What happens if I take an even number and add an even number?
You get even number.
That is a math theorem. That is a truth that is true. Now, something comes with theorem, and that is it's got to be proven. Well, how do you prove it? That's what that book is all about. Okay, it's proving these truths. Okay, a little bit higher math. We have time. I'll do it at the very end. All right, remind me if we have time. Okay, so a theorem is a mathematical truth. Okay, well, Pythagorean comes from a guy. His name was Pythagoras. If you ever played Assassin's Creed Odyssey, you come to a character called Pythagoras, and that's Pythagoras, right? He lived from these ages right here. He had a school of mathematics. We truly don't know if this was his theorem, something he had heard about. All we know is that he wrote it down in a book. Therefore, he's the first person to ever write down the book. He gets credit. Almost all societies that dealt with high-level math came up with the Pythagorean theorem independently. However, he wrote it down, and he gets credit for it. All right. So he was a Greek mathematician, as you can imagine. And his theorem, that's named for him, deals with...
Triangle.
No, it deals with...
Squares.
Right angle.
It deals with right triangles. Okay? And only deals with right triangles. So if you see a right triangle, you can use Pythagorean theorem. In fact, the rest of the chapter is right triangles in the Pythagorean theorem. All right. So it has to be a right triangle. It doesn't work with any triangle. So it's got to be. So you see a little square, you can use Pythagorean theorem. Okay. So we're going to use Pythagoras' definition of the parts of a right triangle. We've talked about right triangles. We haven't talked about the parts. So in box 1, draw me a right triangle. Box 1, draw me a right triangle. There's mine. How do I know it's a right triangle? We got a little square right here indicating 90 degrees at that angle. Okay, not that it's square, but that it's 90 degrees. Okay, we are going to call the two sides of the triangle, look up here, the two sides of the triangle that form that right angle, we're going to call those the legs. Okay, these are his words. He named them. He said the legs of the right triangle. The third side, watch me, that is opposite the right angle. Now I'm going to draw a dotted line. That dotted line is not part of the triangle. That's just indicating what side I'm talking about. The side that connects the two legs, Greek word, called the hypotenuse. Anybody have low blood sugar? It's called being hypoglycemic. Glycemic blood, right? Hypo meaning low, not hyper with an ER meaning too much. So hypo means low. Tenuse means the side that spans the other two. So nobody ever remembers what the word hypotenuse, but that's what it means in Greek. Okay, it's the side that spans the other two. Hypotenuse is what everyone says. Pythagoras was the one write the words, and that's not a right angle. That's not a right angle. That is an acute angle.
What do you mean?
Acute, less than 90.
Yeah, but
That is your right angle. Now erase the other square. Okay. So Pythagoras talked about a right triangle that had legs and a hypotenuse. We will use this so many times that I don't even worry about like spending 5 minutes trying to tell you the names, because you will have them memorized. We will do it at least 100 times between now and the quiz or test. Sorry. All right. So the hypotenuse is the side that is opposite the right angle. Okay, we good? All right. So in box number 2, I've given you 3 right triangles. I want you on each one. You can put L for leg, H for hypotenuse. Label the legs and the hypotenuse of all 3 triangles. It should take you all of 10, 15 seconds. Label the legs and the hypotenuse of all triangles that are listed there. Eyeballs should go to the square, the side that is opposite the square. I'm always going to put a dotted line. You don't have to put a dotted line, right? You don't even have to put this arrow. The side that is opposite the right angle is called the hypotenuse. The other 2 sides are your legs. On the red one, here's the right angle. The side that is opposite is the hypotenuse. The other 2 sides are your legs. On the yellow one, the side that is opposite, the hypotenuse. The other 2 sides are your leg. Who's lost? You absolutely, positively have to be able to do that to use the Pythagorean theorem, right? If you can't do that, you will get every Pythagorean theorem wrong. The key to it is not the legs, the hypotenuse, being able to identify the hypotenuse, because I can turn that right triangle, as I did here, a whole bunch of different ways. Who's lost? Okay. All right. Now for the Pythagorean theorem. Here's what Pythagoras said 2,000 years ago. Okay. He said that if you have a right triangle with hypotenuse C and legs of A and B. So basically he named his 2 legs A and B, and then he named a hypotenuse C. These are just names. You're like, why did he say hypotenuse? He did. But he used letters to represent those because he's just as lazy as I am. I don't want to write the word hypotenuse. I'm going to write C. Okay? So I have legs of A and B and hypotenuse of C. Here's what he proved to be true. That if you square A and you square B and you add them together, you get C squared. Here's what he said. He said if you square A would be a distance. If you square b, b will be a distance, and add them together, you will always get this value, c squared. This is so incredible and so important. Heck, there should be angels singing right now.
Wait, what?
All right, that is Pythagorean theorem.
How the-
All right.
like, it would be that, and then like, say like it was like 2 and like 4.
All right, so we're gonna do plenty of. Now, I said that a theorem is something that you prove to be true, a mathematical truth. In high school geometry, the very next thing we would do is prove this, because you can't just accept this as being true unless someone proves it to you. So, believe it or not, you guys are not smart enough, but you don't have enough knowledge yet to prove this. I can show you a visual proof. So here's a visual proof. Square means what?
2.
Doesn't mean 2. Square means literally what?
Cube.
Why would you say cubed? It's a square.
Cube.
2 is square.
But it's
A cube is 3 dimensions. A square is 2 dimensions. When you see this, we use the word square because we literally mean
Square.
a square. When we see this too, we literally mean.
Square. Square.
So here's your visual proof. I'm going to make squares of A, B, and C, and I'm going to fill them full of water.
Oh.
not a good.
Watch me.
Is that
A
not
square, a square, and a square, and they're filled with blue water. Pythagoras said that if you square the 2 legs and add them together, you get to the square of the third side. There's your proof.
Wait, how does that?
How does that work? What?
If you square the hypotenuse, it is equal to the sum of the squares of the other 2 sides. There's your visual proof.
What?
How is that? What?
Wait, I'm so.
If you square the 2 sides, the 2 legs of a right triangle, it is equal to the square of the third side. There's your proof. All right,
That doesn't make sense.
that is the Pythagorean theorem. You square the 2 legs first by PEMDAS, add them together, and it will equal, you just saw it, it will equal to the hypotenuse squared. Okay. So, great. So what? Well, we can use this on a right triangle when I have 2 of 3 sides. Notice, I'm missing the what? I'm missing the hypotenuse. So we have to find out what the hypotenuse is. So here's how it's done. We start with the Pythagorean theorem. Same 4 steps. Identify the shape, right triangle. Write the formula, plug in the numbers. Where's the hypotenuse? It is the unknown. So C is your unknown, but I do know what A and B are. A and B are, so I just plug those numbers in. C is my unknown, so it stays there, but my other 2 numbers are 3 and 4. Now the question is, which one is A and which one's B? Does it make a difference? Because 3 squared and 4 squared, no matter if they're A or B, if you add them together, you get the same number. 3 squared is, 4 squared is, I don't want to go too fast. You with me?
Yeah.
What's 9 plus 16? Does that say C or C squared? Well, how do you get rid of squaring? Oh, absolutely not. What is the inverse of addition? What is the inverse of multiplication? What is the inverse of squaring? Square rooting. So to get rid of this 2, we don't divide by 2. We take the square root of both sides. What's the square root of 25?
I got a question.
C, I'm sorry, the square and the square root cancel each other, so we're just left with C. So C equals 5. That's how it's done. Yeah.
I got a question. So if you did, instead of taking away the square, then you just did 50, it would have had to be
You got to say a little bit better than that.
okay. If you squares 25, and then that would be 50,
No.
then you weight it.
25 squared is not 50. Not 25 times 2. Do 25 times 25. All right. If you think of it better, ask me again. All right. Once again, here's how it's done. Step number 1, well, it's a right triangle. Step number 2, To find the unknown side of a right triangle, you write the Pythagorean theorem. A squared plus b squared equals c squared. That's also why it's memorable, because it's kind of flows, right? It's easy. The side that is opposite the right angle is the hypotenuse, so we are solving for c. I plug in the two legs for a and b, solve for c. 5 squared is 6 squared is, well, what's 25 and 36?
61.
61. And how do we get rid of squaring? Oh, guess what you just got? We got the non-perfect square, so we squeeze it. Two perfect squares. 64 is bigger, and 49. What is it closer to? 64 or 49?
64.
So it's not 7.5, it's bigger. 7.8. 7.8 is a good guess. Okay. Am I going to make you do what you did last night for homework? No. You just simply need to get to the nearest tenth. Okay. But you now know how to estimate that pretty quickly. Who's lost? This is what it looks like solving for C. We'll get to A and B a little bit later. All right, box 4, here we go. Let's do it. Step number 1, identify the shape right triangle. Step number 2, write Pythagorean theorem. Step number 3, maybe call it 2B. Step, make sure you identify the hypotenuse. I'm giving you them nice and friendly to start, and then I'll flip the triangle over. Sometimes that causes problems. Find the hypotenuse first. The hypotenuse is the side that is opposite the right angle. There's your C. Okay? So I'm solving for C. Stop me if I'm going too fast. Your two legs are 6 and 8. That's your A and your B. So we plug in 6 and 8. Why did I have you memorize box 1? No, these are the numbers we're dealing with. Rarely will I give you 71 squared. I'm going to give you, I don't know, 6 squared. You should be able to throw those answers out really quickly. 6 squared is 36. 8 squared is 64. Grayson, 36 and 64? What's the square root of 100? That's why I had you memorize box 1. He did that one like that. Who's lost? By the way, boy, do we get lazy in math as we get higher and higher in the grades. What have I been skipping each and every time? No units. You're going to see that math books, don't follow middle school math teachers, and all of a sudden units become, hey, yeah, whatever. Yeah, they're units, right? Really bad practice not to put units, okay? Yes, I'm just as bad as every other mathematician. I get lazy as well, too, and we're kind of just happy that we're doing Pythagorean theorem. On any word problem, you have to put units. That's my rule. On any other one, if they give you units, put units. If not, then we'll be okay. The focus becomes in higher level math, the process, getting to the answer, and less the units. You walk in a science classroom, they'll throw stones at you if you don't have units, right? Yes?
You did this.
You should have, right? Pythagorean theorem? All right. Here we go, box 5. The one on the left, let's see, side opposite the right angle is hypotenuse. That's your C. My two legs are 4 and 3. So I get what, 4 squared? Do I have the answer worked out now? I don't know. So 4 squared plus 3 squared equals C squared. 4 squared is 16. 3 squared is 9. 16 and 9. 25 is equal to C squared. We take the square root of both sides, so C is equal to, boom. Second one. Side opposite the right angle is your hypotenuse. So once again, we're solving for C. So we get 5 squared plus 12 squared equals C squared. So that's 25 plus 144. 169, box 1. That's one of those numbers in box number 1.
13.
So we get C is equal to 13. We call any right triangle where all 3 sides are a whole number, we call them Pythagorean triples. Why do we call them Pythagorean triples? Because instead of getting a decimal number, all 3 sides are whole numbers. C is 5, C here is 13. Here are two Pythagorean triples, the two most common. Triples because all three numbers end up being whole numbers. 3, 4, 5 is the most commonly used right triangle for a math teacher. Literally, we call it a 3, 4, 5 triangle. Why? It's really easy to remember. 3, 4, 5. 5, 12, 13 is your other one. If you can keep that in your head, you're going to see these two triangles over and over and over again. Why? Because they're easy and nice friendly numbers. Okay?
I'm trying to find
All right, we just solved what, 6 or 7 problems for what number or for what part of the triangle? C. Now let's solve for A and B. Okay. Yes. No. Okay. Let's solve for A and B. Hey, notice the side that is opposite the right angle is the hypotenuse. Now I know the hypotenuse. I'm missing one of the legs. What do you want to call it? A or B?
A.
Does it make a difference? It does not. So if you want to call that missing side A or B, it's your choice. I'll call it B. Okay. I plug in my numbers this time. This one will be slightly different. 12 squared is
144.
13 squared is. Okay. Notice, okay, this one's solving for not the hypotenuse, solving for the leg. 2 steps of algebra. How do we get rid of 144? Subtract 144 from both sides. You see that?
Yeah.
That ends up being 25. Last step. What did I say the most common Pythagorean triple was after 3, 4, 5? 5, 12, 13.
14.
Okay. It is the most common Pythagorean triple after 3, 4, 5. You will see this question over and over and over again. As soon as you see 12 and 13, as long as 13 is the hypotenuse, right? If 13 was a leg, then it's not 5, 12, 13. 5, 12, 13, yes or no? We'll see. All right, here we go. What are we missing here? A leg or a hypotenuse? By the way, this is box 6 that you're supposed to be doing. Okay. So we're missing what? A or B?
A.
I'll call it, you can call it B, I'm going to call it A. It doesn't make a difference. Okay. Plug in the numbers. 10 squared, that's easy. 26 squared, I'll give it to you, 676. What do we do next? How do we get rid of 100? That gives us,
576.
take 100 away. You can do this in your head.
Oh, why?
It's 570.
You got it, you got it. Last step, Kai. Last step.
Find the script.
How do we get rid of the 2? The inverse of squaring is square rooting. Take the square root of both sides. Who did it? I'm going to claim that this is 5, 12, 13. No, it's not. It's 10, 24, 26. I'm going to claim that this is 5, 10. I'm sorry. It's 5, 12, 13. Why am I claiming that?
The whole number.
It's just double. Double 5 is, double 12 is, double 13.
Hey, I'll be 12.
Teachers, math teachers love the Pythagorean triples.
Hold
So do science teachers. You got to ask a question, not make statements. Ask a question if you're lost. All right. Box 7. Yes. Only if it's isosceles. The only one that you could solve is a right isosceles triangle, where that's x and this is 13. Right? Now I could solve for that, right? Well, a squared, that would be x squared, plus b squared, that would be another x squared, equals 13 squared. X squared plus x squared is? What's anything added to itself? 2 of them. 1 water bottle plus 1 water bottle is not 4 water bottles. It's 2 water bottles. 2x squared. okay, equals 169.
How'd you want to do that?
13 squared. Divide everything by 2, and then take the square root. Okay. I've never actually asked that question other than for high school students, but that's how it would go. And it's the only one that you could solve, at least at this level. All right, who is not done with these two? All right, first one, let's see, I'm missing the A. So I would get what? A squared plus 8 squared equals 10 squared. Well, that would be A squared plus 64 is equal to 100. Subtract 64 from both sides, and we get 36. So we get A is equal to 6.
That's a whole number.
Okay. 3, 4, 5. All I did was double every number. Double 3 is 6, double 4 is 8, double 5 is 10. It's still Pythagorean triple.
How?
I just told you how.
I know, but like you said-
Double 3 is 6, double 4 is 8, double 5 is 10.
Yeah, I thought you said it was only like 12, 5, and one other.
It is, and then you can do scalar multiplication. In other words, you can double, triple, quadruple those numbers and get another Pythagorean triple. There are more, but those two, 3, 4, 5, and 5, 12, 13 are the most common ones. And then you can take those and double, triple, quadruple them to get another one. But there's plenty more. I'm just trying to give you a heads up that you're going to be seeing those 3, 4, 5, 5, 12, 13 for the rest of your math career. All right, so we did that one. We got to 6. This one, let's see. We got A squared plus 7 squared equals 25 squared. That would be A squared plus 49 is equal to, who's got it? 25 squared is
625.
625. We got to subtract 49 from that, and we get,
576.
and we've seen that number before. A couple slides ago. 576 was 24 squared, so we get A is equal to 24 after we take the square root of both sides. Okay. This is Pythagorean triple as well too. Just not a very common one. 7, 24, 25. Okay. I think this is the only time I've ever used this one on this one slide. I've never used that Pythagorean triple ever before. All right. We good? So let's see. We've solved for hypotenuse. We solved for a leg. Seems like everything there is to know about the Pythagorean theorem. Oh, there's more. All right. Last new thing is this. Okay. We know that if you have, this is the previous slide, that if you have a right triangle, what's always the longest side? What's always the longest side? The hypotenuse. So if it is a right triangle, the longest side will always be, well, let me back up. If you have a right triangle, then the hypotenuse is always the longest side. So look at box number 8. Look at box number 8 and write these 4 steps down. Tonight for homework, they're going to give you 3 sides and they're going to say, does it make a right triangle? No, they don't literally want you to draw this. We're going to algebraically see if this is true. So step 1, you write the Pythagorean theorem. Base just means without any numbers in it. Step 2, plug in the longest side that you're given for C. And the other 2 sides are your A and your B. Step 3, do the math and see if the left side of the equation equals the right side. If it does, it's a right triangle because A squared plus B squared would equal C squared. But if it doesn't, it could be a triangle. It's just not a right triangle.
Wait, are you writing these down?
Yes, because I didn't give them to you.
You should have highlighted.
I could have.
Yeah. I thought we had the actual solid triangle instead.
Right, and then you would need a protractor, right? Here's a way of doing it without drawing anything. Step 1, you write the Pythagorean theorem. Step 2, identify the longest of the 3 sides, plug it in for C. The other 2 become A and B. And then just basically the rest of the steps are see if the left side equals the right side. Yes, Winter.
So when we do it on the homework, you want us to say
It's yes or no.
yes or no?
Yep.
Okay, I wanted to make sure.
Yep.
All of them are like the same answer except for 1 or 2. For that.
All right, we good? Let me show you how this works.
Oh,
Here's how it works. Is it a right triangle? Tonight for homework, they're going to give you
Yes.
3 sides. Well, this is Pythagorean Triple. We already know this one is. They're going to give you 3 values. You're going to say, does it make a right triangle? Step 1, you write your base Pythagorean theorem. That's a squared plus b squared equals c squared. Step 2, what's the longest side here?
5.
5 is your c. The other 2 are a and b. See what it did? Now we see if left side equals right side. 3 squared, 4 squared,
16.
5 squared.
25.
Does 9 plus 16 equal 25?
Yes.
The answer is yes. Okay. It will be a no. What will happen is this might be a 20. You'll get 9 plus 20. Well, that's not 25.
If you know it's Pythagorean,
Yeah. If you know it's Pythagorean triple, put a yes and you're done. Okay. Pythagorean triple?
yes,
How do you know?
12, 4.
Don't just assume that I put 3 numbers. It's Pythagorean triple.
No, it is. 'Cause, like,
Which one is it?
6. It's like 12 is a 6.
That's not.
If you double 3, you get 6. There's no 6 here.
Yeah, but the 12. 12.
Okay, so you're multiplying by 4. So I got to multiply 3, 4, 5 by 4.
Oh, wait.
4 times 5 is 20. There's no 20 up here.
It's no.
Never mind.
Okay.
Never mind, no. So
Also, don't assume, because I haven't shown you all Pythagorean triple, that you can pick it out. So the easiest thing is just plug in the numbers. What's the longest side?
12.
12. 12 is your C. The other 2 sides are your A and B. Stop me if I'm going too fast. 8 squared,
64.
4 squared,
16.
12 squared.
1.
Is 64 plus 16 equal 144?
No.
Not a right triangle. It could be a triangle. In high school geometry, I will show you whether or not it even can make a triangle. 3 sides don't always make a triangle, right? If you have a really long side and 2 really short sides, that doesn't make a triangle, right? So don't assume it even makes a triangle. That's more of a high school thing. All right, so this one is a big fat no. Does that look like Pythagorean triple?
yeah.
Which one?
Well, never mind.
If you don't know,
Yeah, 10.
is it a 3, 4, 5? Then what are we multiplying by?
5.
5 times 5 is 25. There's no 25 up here.
What you said? You said.
If it's a Pythagorean triple, the most common ones are 3, 4, 5, and 5, 12, 13.
Yeah, there's no.
12.
Agreed, but that all of them have to be multiplied by the same number.
They do?
Right.
Oh.
All right.
We should.
There's a 12 of
But there are many other Pythagorean triples out there. All right. The longest side here is
20.
20. So 20 is your C. You're supposed to stop me if you're lost. Jaden, 12 squared.
12 squared is 144. 100.
200.
I don't know 20.
Okay. Well, what's 2 squared?
2 squared is 400.
400. Okay. Yay, nay?
Nay.
That's a big nay. Yes? We good?
Yep.
All right. All by yourself, Buxton.
So I remember how to do it.
Go. Give him a chance. Give him a chance.
Okay.
Go. Jackson, first one.
So 15 is the biggest number.
So that's your C.
And then 9 squared is 81. 12 squared is 144.
Add those 2 together and you get?
225.
And 225 equals 225. Hey, which one is it? That's a 3, 4, 5. What are we multiplying by? We're multiplying by 3. 3 times 5, 15. 3 times 4, 12. 3 times 3, 9. Some people will be able to recognize these, but most of us won't. Just do the math. It doesn't take that much work. All right, last one. Who's got it? Okay. Largest one is 20. Jaden told us that 20 squared is 400. 15 squared is, that's one of the ones you're supposed to have memorized.
I don't have it all up there.
225, and 12 squared is, does that add up to 400?
No.
No. Do you actually have to do all of the work? Well, you can kind of take a shortcut here. 5 plus 4 is 9, not 0. So that's a no. Okay. We did 3 things today. Pythagorean theorem. Is it a right triangle? And is it? We did the Pythagorean theorem for solving for both a leg and a hypotenuse. Wizard of Oz. What's that got to do with Pythagorean theorem?
Everything, because it's
Anybody ever watch the ending of the Wizard of Oz? What does the wizard say to the scarecrow? What is the scarecrow trying to get?
give me the parrots.
A brain. And so he says the following.
Back where I come from, we have university seats of great learning, where men go to become great thinkers. And when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitatis Committee Artem e Pluribus Unum, I hereby confer upon you the honorary degree of PhD. PhD? It's Doctor of Thinkology. Some of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Oh, John, I've got a brain. How can I ever thank you enough?
No, he doesn't.
You can.
That's not the Pythagorean theorem. He's trying to say the Pythagorean theorem and he screws it up. He said that instead of saying the squares of the side of a right triangle is equal to the square of the hypotenuse, he instead says the square root of any two sides of a right triangle, an isosceles triangle, is equal to the square root of the third side, which is false.
Yo, that sounds like
So only a math person recognizes what he's trying to do. Is people think that smart people know math. Well, I guess the whole moral of the story is everyone has a brain. You don't need to be given a brain. And it's kind of a play on words there. All
What
right.
is argument error?
Argument error is what you do. You have some gradients, so you're trying to do two different things at the same time. Take it out of gradients, put it back in degrees. You want to see that thing again? So remember, square literally means square. So if we square this side and add it to this side, it'll equal the square of the third side. And that's what it's showing you. It's showing you that visually that the square of this plus the square of this is equal to the square of the third side. Because the hypotenuse is the biggest side. The hypotenuse is the biggest side. Remember, if the hypotenuse is the biggest side, it would make the biggest square.
How does that work?
What about, because it's not isosceles. The two legs are different sizes, so you're going to have a small square and a medium square, and a big square. Oh, no, I promise you 2 even equals even. All right. So an even number can be written as 2 times k. Any even number. Give me an even number. That's 2 times 2. Give me another even number. That's 2 times 3. So if I take 2 and I multiply it by another number, call it k, you get an even number. Second even number, we'll call it 2 times L. Okay? So when we add these two together, we get 2k plus 2L. Right? Well, I can divide a 2 out of both of these. That would be 2 times k plus L. K plus L will be another number. You add k and L, you get another number. We call it M, and you get 2L. And I define an even number as 2 times another number. Therefore, when you add 2 even numbers together, you get another even number. All right. All right, Donovan, we are done. Any questions?
No, I kind of picked this up pretty good.
All right, cool. If you have any other questions, send them to me, chat, or email as you always do, and we'll see you tomorrow, Donovan.
Okay, bye guys.